This experiment focuses on understanding the fundamental properties of fluids, particularly density, specific gravity, and specific weight. These properties are important in hydraulic engineering because they influence how fluids behave under different conditions. The objective of this activity is to familiarize students with different fluid properties by measuring and comparing density, specific gravity, and specific weight of various liquids. Through this experiment, students gain practical experience in fluid measurement and learn how fluid properties affect engineering applications. At the end of this experiment, students are expected to compute and compare the density, specific gravity, and specific weight of different fluids. Students should also understand the relationship between mass, volume, and weight in fluid measurement. In addition, this activity helps develop accuracy in laboratory measurement and data analysis. Fluids are substances that continuously deform when subjected to external forces. Unlike solid materials, fluids cannot resist shear stress without undergoing deformation. Fluids can be classified into liquids and gases. Liquids maintain a definite volume but change shape based on their container, while gases expand to occupy the entire container. One important property of fluids is density. Density is defined as the ratio of mass to volume. It determines how compact or heavy a fluid is compared to its size. Density is affected by temperature and pressure. For example, water has a density of approximately 1,000 kilograms per cubic meter at 4 degrees Celsius. As temperature increases, fluid density usually decreases because fluid molecules move farther apart. Another important property is specific gravity, also known as relative density. Specific gravity compares the density of a fluid to the density of a reference substance, which is typically water for liquids. This value has no unit because it is a ratio. If a fluid has a specific gravity greater than 1, it means the fluid is heavier than water. If it is less than 1, the fluid is lighter and may float on water. Specific weight, on the other hand, is defined as the weight of a fluid per unit volume. It is calculated by multiplying density by gravitational acceleration. Specific weight is important in hydraulic engineering because it determines the pressure exerted by fluids and influences fluid force calculations. Understanding these fluid properties is essential in designing hydraulic structures, pipelines, storage tanks, and fluid transport systems. Engineers rely on accurate measurement of fluid properties to ensure safety, efficiency, and proper system performance. To conduct this experiment, the beaker was first cleaned using running water and dried using a clean towel to remove contaminants that could affect measurement accuracy. Next, the mass of the empty beaker was measured and recorded. This value served as the tare mass for determining the mass of each liquid sample. The beaker was then filled with a liquid sample, and the total mass of the beaker with the liquid was measured and recorded. The mass of the liquid was determined by subtracting the tare mass from the total measured mass. This procedure was repeated for all liquid samples including water, vinegar, soy sauce, cooking oil, gasoline, and motor oil. After collecting all measurements, the data were tabulated. Density, specific gravity, and specific weight of each liquid were then calculated using appropriate formulas. In conclusion, the experiment successfully demonstrated how density, specific gravity, and specific weight can be measured and compared using laboratory procedures. The activity allowed students to observe how different liquids vary in mass, volume, and weight. Through hands-on measurement and computation, students gained better understanding of fluid properties and their importance in hydraulic engineering. The experiment also helped improve measurement accuracy, data analysis skills, and laboratory techniques. Understanding fluid properties is essential in real-world engineering applications because these properties influence fluid behavior, pressure distribution, and system design. Overall, this experiment helped bridge theoretical concepts and practical laboratory experience, preparing students for more advanced fluid mechanics studies.